Hello everyone, my name is Gad, and in this video I'm going to be showing you how you can lerp over time in Unity. So I'm just going to quickly demonstrate what I've done this for, like how I've used this. So the first thing I've done is over here in the input manager, adding in input smoothing time. So as you can see, when I go left and right with the handlebars, it goes nice and smoothly over 0.5 seconds, and then also returns back to the center over 0.5 seconds. And then another thing I've used this for is having this head position, so it can go, say, like any distance over any time. So if you look at the top right, the Z direction, when I lean forward, it's going to go to 20 over 2 seconds, over 0.5 seconds actually. And so yeah, I'm going to show you how to do this. And in case you're wondering, this is my Unity package where you can use any player model or bike model you have and get them rideable, things like that. So in case you're interested, the link will be in the description. So without further ado, let's go into a new scene and get this all set up working. So what I'm going to do first is add in a sphere and just reset the transform, because we're going to do this for the second thing, so move in the distance over time. And then I'm going to add a component here and then just call this script lerp over time, and a new script, just create an add. And just open up my other script. There we go, double tap it, open it up. First thing I'm going to do is add in a serialized field, and this is going to be a float, and I'm going to call this the smooth time. And then I'm just going to default this to 2. And then I'm going to add another float called the timer, and then another float called the lerp value. So what I'm going to do in the update is just have the timer and then equal this to a mathf.clamp and clamp it between 0 and the smooth time. And also need to have timer at the beginning there, which I always forget. And this is just so the timer doesn't go past the smooth time, because it really doesn't need to, and doesn't go below 0 because it also doesn't need to. So what I'm going to do here is just have an if, and then have input.getKey, and then keycode.w. This is what I'm going to do to trigger the timer. And then so in here I'm just going to have a timer, and then just have a plus equals, and then what I'm going to do here is 1 times time.delta time. And you would be right in thinking that this 1 doesn't actually do anything, but you'll see later why I've done this. I just find it easier to do it like that. So after this, what we can do now is just have the lerp value and then equal this to a mathf.inverse lerp, and then it's going to be between 0 and the lerp, no, not the lerp value, the smooth time, and then timer. So what this does is, depending on the timer's value between 0 and the smooth time, which is 2 here, so if the timer equals 1, then this lerp value will equal 0.5, because the timer is half of the smooth time, or halfway between 0 and the smooth time. So say this was -1 here instead of this 0, and then the smooth time equaled 1. If the timer equaled 0, this would equal 0.5. And then say if the smooth time was 5, and then I'll say 10 because that's easier. If the smooth time is 10 and the timer equals 1, then this lerp value will equal 0.1. So hopefully did a good enough job at explaining that. And then so what I'm going to do is just debug.log this lerp value. And then I'm just going to go in the scene here and then quickly test this works. So I'm going to go on the console, press play, and then hold W. And as you can see, over 2 seconds we get a value of 1. And then so now what I'm going to do is show you how you can get it to go down. It's really simple, it's basically doing the same thing. So I'm just going to have an else, and then if the timer is greater than 0, what I'm going to do is have the timer and then plus equals, And this is why I've had this 1 here, because I'm just going to add in a -1 times time dot delta time. And you could just have a minus equal time dot delta time, but this is just the way I prefer to do it, because sometimes you want to use the same timer but have it go up twice as fast. So you can just change this to a 2, and then this is going to go up twice as fast and go down. So it will go up in 1 second and then go down after 2. So this is why I like to just have the 1 there, so you can change it around. So now we've got this, the timer going down. We can literally just copy these 2 lines here, because it doesn't matter which way it's going, up or down, it's still lerping between the 2 values. So now when we play this, and then I hold down W, you see it go up to 1, I let go and it goes down to 0, and then sort of you can just let go, hold it forward, and it's going to keep going up and down. So now that's done, I'm going to show you how you can lerp between like 0 and 30 over time. And then so what I'm going to have here is just to demonstrate, actually I'm going to add another serialized field and then call this distance. After we define as a float distance, and then equal this to 30. And then under here, what we're going to do, instead of this lerp value, I want this to be the final value. So I'm just going to make a new float and call it inverse t, which is going to just equal the same thing as it did before. And then so now what we can do is just have the lerp value equal to mathf.lerp, and then we're going to have a 0 and the distance. And also what you could do is just have like a minus distance here, or any number you want between 0 and distance, and it will lerp between those values depending on the inverse t, which is a value between 0 and 1, which is what you have to use for a lerp. So now when we run this, the lerp value will go between 0 and 30 depending on the time. So when the timer is at 1, which is half of the smooth time, the distance will be at 15. So now we've got this one done for here, but we're just going to do the same again for it going down. So we're going to add another float and also just call this inverse t. And then I can literally just copy this whole thing here, put it down below. So now what we can do is just check this is all working. So it should go between 0 and 30 over 2 seconds, which you can see it does. When I let go back down to 0. And then so now to visualize this, I'm just going to quickly go and then have a transform position, and then equal this to a new vector 3, 0, 0, and then the lerp value. And then also just copy this for the else. So now when we run it, we can see the ball actually moving, and so we can see direction there. It's going to dock this on the side, press play. So now when we hold W, you can see this is going to go from here to here over 30 units over 2 seconds, and then we let go and it's going to go back in the same amount of time. So hopefully you enjoyed this video and learnt something. If you liked it, please give it a like, that'd be great. And if you didn't like it, dislike it, why not? Subscribe if you want to see some more, and I'll speak to you in the next one. Bye.